So we already did the top in class, and we're going to do the rest of this on here. So basically, the big thing that we're getting out of this is dilations is really scale factors. Okay, scale factors is basically how big or how much smaller something is. So as you can see, what I wrote down, a scale factor is basically how much bigger or smaller a figure is from the original. Now we're going back to your transformation days, your reflections, and all that. We have those little apostrophes. Okay, those letters with apostrophes. Remember, the regular letter is the pre-image. Okay, that is your before. And then you have your apostrophe, which is your image, which is the after. Okay, that's still in play. Okay, now let's go down to the bottom here, where it says the dilation is an enlargement. Okay, dilations is basically you have a figure, you make it bigger or you make it smaller. Okay, so the dilation says when n is greater than 1. Okay, so basically what it's saying is anytime your scale factor is larger than 1, it's going to be an enlargement. Okay, so that means it got bigger. Obviously, enlargement being bigger. Okay, now the next one it talks about is reduction. Okay, let me do this down here. So that means if that means your scale factor is larger than 1, but smaller than, and I wrote it wrong. Larger than 0, smaller than 1. So it's going to be a fraction, okay? Not necessarily, like, don't be confused because this is a fraction as well. But this 5/4 is bigger than 1. Okay, so this one would still be an enlargement. Okay, but when you have something that's bigger than 0 but smaller than 1, then you're going to have what we call a reduction, which means your original figure is going to your new figure is going to be smaller than your original figure. Okay, so that's something to possibly think about as well. So as you can tell, I put in green down here, smaller than original, and that's dealing with the reduction. And then you'll notice here, larger than original. Okay, so that means if it's enlargement, it's going to be bigger than the original or your pre-image, and then your reduction is going to be smaller than your original, or also known as your pre-image. So now the example of analyzing dilations is first we look at our image here, our two figures. Okay, so this one is the pre-image. We know that because there's no apostrophes. And that makes this one the image, the after. All right, so we take a look at their sizes and things like that. So let's just take a look at the bottom. So the AD goes 1, 2 in length. So let's take a look at the image or the after, and it goes 1, 2, 3, 4, 5, 6. So it is 6. Now let's take a look at the sides as well. Let's take a look at from B to A or BA. It goes 1, 2, 3. And then we look at the BA of the B prime A prime of the image. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you notice that is 9. Okay. So then what we're going to do is we're going to set this up in ratio form. Okay. Remember when you guys did ratios, probably back in Algebra 1, and you had two fractions set up, and and you cross multiplied, so you end up with 10x is equal to 36. So x equals 3.6. Okay, we're doing the same thing here in a way. Okay, so to try to figure out what that scale factor is, let's take our BA over our AD, okay, and we'll set it up, and you'll notice that is 3 over 2. Okay. Now let's take a look at the other image where you have B prime over A prime is over A prime over D prime, and that is 9 over 6, which is also, when you simplify it, 3 over 2. So you notice that they are the same. Okay. So now I'm going to erase that, and we're going to talk about doing the scale factors. Okay. So to find a scale factor, sorry about that. Before we get into scale factors, let's talk about how we set up ratios. Okay. So we want to set it up as the the image over the pre-image. Okay, and that's how we set up the ratios for all of these. Okay, so if we would did that over here, if we did BA over B prime A prime, we end up with, sorry, it's the other way around, B prime A prime over B A, you end up getting 9 over 3, which is 3. Okay, notice the image goes on top, pre-image on bottom. So let's do the same thing if we did AB. Okay, so if we have A prime B prime over AB, you end up with 6 over 2, which is also 3. It's the same ratio. So if you have everything to be the same ratio, then yes, this is considered similar. Okay, all the angles, when we talk about things being similar, all the angles are the same, but the sides are different. Okay, and that's what these are. These sides are different, but the ratio is the same. Okay, if the ratios are the same, then they are similar, and I believe that's going to be probably in our next section or our next topic moving forward, talking about similarities and things like that. Okay, so things are going to be similar if the ratios are the same. Okay, so I want you guys to try the next one. Set it up exactly how you did up here. Okay, image over your pre-image, and do that for all 4 sides, and then come back to see if you got it correct. And we're back, and notice that we have everything set up. I tried to color code things so you can see it. Notice too, everything checks out. Everything is 1/3. Okay, so that's how these links are going to be related. Now the angles measures of the two figures related. How are the angle measures related? Angle measures are the same. Nothing changes about the angle measures. Okay, so now let's scoot down to scale factor. So it looks like this is going to be a 2-video one, sorry. 2-video lesson. This define a scale factor is basically exactly how we set it up just above it, okay? We're going to set it up as the pre-image over the image. And we're going to look at their similar sides, okay? So we look at the sides. So we look at LK, and that's your image. Okay, that has no apostrophes. Okay, so we have LK on the bottom, and the image or the after on top, L prime, K prime. So when we write it down, we end up with 18 over 12, and then when we simplify that, that's going to be, both sides can be divided by 6. So that would be 3 over 2. That right there is your scale factor. Okay, so this image, the second image, is 3/2 or 1.5 times bigger than your pre-image. So you have 3.5 times larger than your pre-image. Okay? Okay, you guys try using this figure, this picture for number 6 and number 7. It's asking you, one, is it an enlargement or a reduction? So from the before to the after, is it getting larger or is it getting smaller? On number 7, it is, okay, what is the scale factor? Okay, so what is that number it is getting larger by? What is that number it's getting smaller by? How much bigger is it or how much smaller is it? Pause, work it out, and come back with the answers. And we're back. So, on number 6, the dilation is enlargement or reduction. Well, hopefully you went by the points and the primes and things like that, the apostrophes, other than left to right. Okay, make sure you pay attention to the points. Do they have apostrophes or not? Well, because this one is your pre-image, and this one is the image. So the smaller one is the after. So we went from bigger to smaller, which is the reduction. And then the next one is the scale factor. When we set it up, you end up with 1/2, which is 1/2. So that means the image is half as big as the original. All right, so now we're doing the dilate a figure with the center at the origin. Okay, so it says, what's the vertices of dilation of ABC? And it says notation of this means what is the image after a dilation centered at the center of the origin with a scale factor of 3. Well, that should be in there. It is not. Apologize for that. Okay, my copying pasting skills are lacking these days. So, but that is what that should. That's basically what that should say. Okay, that is basically saying this is the scale factor. Define a dilation when it's right at the center. When a dilation is the center at the origin, this is really actually easy to do. Okay, so we know our scale factor is 3. So what we're going to do is we're going to take every point and multiply it by 3. Okay, so you have A, which is 1, 2, so 2, -1. So we're basically going to take this and multiply it by the scale factor, which is 3. Okay, so for example, we're basically just distributing, so your A prime is going to be 6, -3. We're going to do the same thing with B. Okay, so B is -1, 2. So we multiply it by the scale factor, which is 3. We end up with -3, 6. And then C, that's B prime. C is 3, 0. And then we multiply it by the scale factor. So C prime is going to be 9, 0. That's all you have to do, especially when it's the dilation is center at the origin. Okay, all you're doing is multiplying every single coordinate point by the scale factor. Okay. Okay. So now I even rewrote that to where maybe you can put that as well. Okay. Now, only works for this particular one. There's going to be a different one, and when we do the different one, you have to apply that method as well. Okay, I'm going to end this one here and start up with a new one after this.